Hello there, it's me, Statistics Salazar Slytherin, talking to you about histograms. Now here's the question, where does Dumbledore keep his armies? In his sleeveys! Ah!
First thing we're talking about is data. Data is factual information like measurements or statistics used as a basis for reasoning, discussion, or calculation. So today we are going to take a group of data and organize it into either a table or a histogram or a chart. Now, a histogram is a bar graph that shows the frequency or number of times a data item occurs. So here you can see we have certain data items organized based on the amount of years that someone was educated. And with those years, on this side, we have the percent of the population surveyed that fall within those categories. This will either be a percent or just a frequency number, just how many times did it occur. Now here's some shapes of histograms that I want you to memorize. There is a symmetric histogram, or bell-shaped, where you can see that it peaks in the middle, kind of looks like a mountain. The bimodal, or two peaks histogram has, as you guessed it, two peaks. A uniform histogram is the same frequency, more or less, all the way across the board. A skewed left histogram actually looks like it's skewed right. It's kind of weird. So here the skew left histogram has more data points on the right than on the left, whereas a skew right histogram has more data points, more frequency on the left than on the right. So again, just think about it being the opposite. Skew left means there's going to be more on the right. Skew right means there's more on the left.
How does a wizard get into their house? Through the Griffin door! Ha ha! Example time!
Now example 1 says, according to the histogram, which drinks contain the same amount of sugar? So we're looking through this and we see which drinks have the same amount of sugar. Well, we're just looking for the same number of spoons, right? So we start with orange juice and regular Coke. For sure, they have the same amount of sugar. You can see 10 and 10. Next, we can see that water and lime and coffee with sugar also have the same amount of sugar. I think that's it. We did it. Next, according to the histogram, what two drinks combine to equal the same amount of sugar in large Coke? Large Coke, that has 12 spoons of sugar. What things can add up to 12? Well, there's a couple different ways you could add up to 12. We can take the orange soda and add it to the water and lime, right? 11 plus 1 gives you 12. Sweet. Next, the orange soda and coffee with sugar. Because water and lime and coffee and sugar are both 1, they would both add with the orange soda to equal the same amount of sugar that's in large Coke, 12. Next, Diet Coke and Gatorade. If you were to add these together, 7 plus 5 also equals 12. So that's another combination. And then we also have large Coke and water, because 12 plus 0 is still 12. And I think that's all of them, so we're done. Next, we need to figure out where's the air in this histogram. Well, each of these spoons represents a teaspoon of sugar in 12 ounces of the beverage. If we know that a spoon represents a teaspoon of sugar, then this 0 with a spoon doesn't make any sense. If there was no sugar, there should be no spoon. So because of that, we could say that that is the error.
How does Harry Potter get down a hill? Walking. JK Rowling! You try.
Okay, this time it says the graph below shows the number of countries students in a class have visited. How many students have visited 4 countries? So we look across and number of countries visited, that would be 4. That would be this guy right here. So number of students then would be 5. So 5 students have visited 4 countries. Next, how many students have visited either 3 or 4 countries? So we're going to have to combine those. So we look and we see, okay, 3 or 4 countries. That would be 5 students for 3 countries and 5 students for 4 countries. If you're saying how many students have visited either 3 or 4, then you add those together and you get 10 students. Lastly, would it be accurate to say that the majority of students have visited 3 or more countries? Why? So we need to figure out how many students have visited 0, 1, or 2 countries, and how many students have visited 3, 4, or 5 countries. So let's add these together. Students that have visited 0, 1, or 2 countries, we add the 3 plus the 8 plus the 3, and we end up getting 14 students. We then go over here, and we say how many students have visited either 3, 4, or 5 countries. We add the 5, 5, and 2, and you get 12. So would it be accurate to say that the majority of students have visited 3 or more countries? No, actually more students have visited 0 to 2 countries, and then you're done. Now, example 2 says the graph below shows the results of last year's final exam. How many students earned from 80 to 100%? So down here we have our percentage, and 80 to 100% would be these 2 columns. So let's go ahead and figure out the number of students in each of these columns. Well, number of students, that would be over here. And since we're going by 2's over here, this one is about halfway between the 12 and the 14. So that would be 13 students. And this one is about halfway between the 4 and the 6. So that would be about 5 students. So 13 students plus 5 students, that's 18 students. Now, which score intervals have the same number of students? So we look down here and we want to see which score intervals have the same frequency. So we see over here that this red rectangle and this yellow rectangle go up the same height, which means that the score range from 20 to 30 and 40 to 50 both have 1 student in them. Therefore, they have the same number of students. Same thing with the score range from 30 to 40 and 50 to 60. Each of them have 2 students, so they would have the same number of students as well. Lastly, if a test is chosen at random and the score is 72, how many possible students could have earned this score? So we look over here and we see that the number of students that scored between 70 and 80, which is where that 72 would lie, is about 9, right? It's 9 students that scored between 70 and 80. Therefore, there's 9 possible students that could have earned that 72.
Why did Voldemort have such a potty mouth? Because he kept using unforgivable curses! Ha ha! You try.
Okay, this time it says the histogram below shows the number of times 100 students viewed the music video for Despacito on YouTube. Part A, how many students have seen the video 6 or 7 times? So we look over here, 6 and 7, so that would be these 2 rectangles right here. So how many viewed it 6 times? That would be about 7. And then how many viewed it 7 times? That would be about 10. So 7 plus 10, 17 students. Next, how many students have viewed the video fewer than 4 times? So fewer than 4 times, that would be 1, 2, or 3 times. So we go ahead and add those number of students together. 8 plus 11 plus 11, that's going to give you 30 students. Part C, would it be accurate to say that the majority of students have seen the video 7 or more times? Why? So 7 or more times, so that means we're adding together 7, 8, 9, and 10. And we also have to add together the 1, 2, 3, 4, 5, and 6, right? So if we add these together, 8 plus 11 plus 11 plus 10 plus 7 plus 7, we get 54 students. Next, if we go ahead and add the 7, 8, 9, and 10, we are going to add 10 plus 12 plus 9 plus 15, and we get 46 students. So then, would it be accurate to say that the majority of students have seen the video 7 or more times? No, only 46 students have seen the video 7 to 10 times, while 54 students have seen the video 1 to 6 times. So that's what you would say. Lastly, could you say that the majority of students tried to salsa dance while listening to the song? There's no information from that table that would allow you to say that, but you definitely did. Example 3 says use the data to make a frequency table and a histogram. So here we have marathon times in minutes, and they're all out of order. So anytime you're given a bunch of data and it's not in order from least to greatest, you need to order it from least to greatest. Now we can work with this. So what we're going to do is we're going to create a frequency table. One of these columns is going to be an interval of minutes, and the other one is going to be the frequency. How many instances does that time appear on this data set? So here's the deal. The way you break this up, your time intervals could be different than my time intervals. I'm going to go by 20-minute intervals, whereas you could have done 15 or 10. And if you did that, you would have just had more rows in your frequency table. And that's okay. Now, I'm going to go from 130, start at 130, and I'm going to go 20. So from 130 to 149. And then I'm going to go from 150 to 169, 170 to 189, 190 to 209, 210 to 229, and then 230 to 249. That should take care of everything that's in the table, right? Because our last data point is 246. So yes, perfect. Now we need to figure out how many instances in this particular data set occur within our given time interval. So let's do it. 130 to 149. How many times does that appear up here? Well, it looks like 135 would be the only one, right? So that would be a frequency of 1. Next, 150 to 169. Well, 161 falls in that interval, 167 falls in that interval, 175 does not, so it would be at a frequency of 2. 170 to 189. Yes, that falls in that interval. Yes, falls in the interval. No, outside the interval. So again, a frequency of 2. 190 to 209. Yes, in the interval. Yes, in the interval. Yes, in the interval, just barely. So that would have a frequency of 3. And then 210 to 229. Yes, yes, and then no. So again, a frequency of 2. And then 230 to 249. Yes, it's in the interval. Yes, it's in the interval. Therefore, we have a frequency of 2. So we have filled out our frequency table. It's time for a histogram. So we create our histogram where our minutes are going to be on the x-axis and our frequency is going to be on the y-axis. Now, on the y-axis, since it's frequency, it just goes by ones in this case because our highest frequency is 3, right? So we would go 1, 2, 3, 4, 5, and 6. Then the minutes, the intervals, are going to go down here. Now, this little guy right here, what that does is it allows us to not start at 0. This just tells us that we're skipping a bunch of numbers, and then we're going to start at 130 to 149, and then 150 to 169, 170 to 189, 190 to 209, 210 to 229, 230 to 249. It would be really annoying to have to go 0 to 19, 20 to 39, and then do that all the way where there's not even going to be any data points over there. So that's why we do this. Now we make our histogram. So we go to our given time interval. It's a frequency of 1, so we go up to 1. Next has a frequency of 2, so we go up to 2. Next one has a frequency of 2, up to 2. Next one has a frequency of 3, so we go up to 3, then 2, and then 2, and then you are done. Look how easy that was.
How does a wizard get rid of a rash? With Quidditch! Ha ha! You try.
Okay, doing the same thing here. Make it a frequency table and a histogram. So anytime you're given data that's not in order from least to greatest, put it in order from least to greatest. It'll be much easier to work with. Next, we create our frequency table where we're going to have a point interval over here in this column and then the frequency at which that occurs in this column. Now our point intervals, they could vary. You could have different intervals than I do, but I'm going to choose, let's say, 5-point intervals. So we'll go from 1 to 5, 6 to 10, 11 to 15, 16 to 20, 21 to 25, and then anything bigger than 25. That will be our last interval. Now, let's go ahead and figure out the frequency at which these data points fall in these intervals. So, from 1 to 5, 2 is in, 5 is in, 8 is not. So, we have a frequency of 2. From 6 to 10, 8 counts, 9 counts, 10 counts, 10 counts, 12 does not. Therefore, we have a frequency of 4. From 11 to 15, yes, 12 is in, 13 is in, 13's in, 13's in, 16, no, that's out. So we would have a frequency of 4. 16 to 20, yes, that's in, 17's in, 18's in, 18's in, 20 is also in, 21, not. So we'd have a frequency of 5. 21 to 25, 21 is in, 22 is in, 33 is not. And then anything bigger than 25, that's where that 33 comes in, so that would be a frequency of 1. Sweet! Now that we have finished making our frequency table, we can make our histogram, where our points are going to be on the x-axis, and then our frequency is going to be on the y-axis. Now, since our highest frequency is 5, we don't have to count by 2s or 5s here. We can just go up by 1s. 1, 2, 3, 4, 5, and 6. For our points down here, our intervals, we start with 1 to 5, then 6 to 10, then 11 to 15, 16 to 20, 21 to 25, and anything bigger than 25. Then for our histogram, all we have to do is just make a little rectangle that goes up whatever the frequency is for that given interval. So our frequency is 2 for the first interval, so we go up to 2. Boom. Our interval from 6 to 10, our frequency is 4, so we go up to 4. Then from 11 to 15, our frequency is 4, so we go up to 4 again. From 16 to 20, our frequency is 5, so we go up to 5. Then from 21 to 25, our frequency is 2, so we go up to 2. And then anything greater than 25, our frequency is 1, so we go up to 1. And that's it. You did your histogram. Now, example 4, we're going to describe the shape of each histogram. So remember, we had some vocabulary terms to describe the shapes of histograms. This one looks like there are 2 peaks, right? It doesn't peak in the middle. Instead, it peaks twice. So that would be bimodal. Next, we have the same frequency all the way across. That would be uniform. Then part C, it looks like the majority of our data is on the left side and then it slopes off to the right. So because the majority of the data, the frequency is on the left side of our histogram, that means that it's going to be skewed right. Remember, right skew, because it's the opposite of where most of the frequency occurs. And then, last but not least, it peaks in the middle and it's the same on both sides. It kind of goes up and down like a mountain. You know that's going to be symmetric or bell-shaped. Some people also refer to this as a normal curve, and we'll talk about that later on.